Okay. All right. Let's go with chapter 1 again. What is chemistry? The study of matter and the changes in matter. Got that? Number 2. What are CFCs? Put your phone up, please. Ready? CFCs. Everybody know the story about that? Chlorofluorocarbons, and good or bad? Well, they were good for air conditioning, but when they got in the upper atmosphere, they did what? They broke down the ozone. What's ozone? O3. That's right. Okay. What does ozone protect us from? Okay. Next, steps to the scientific method. Make a good observation. What does recognize and state the problem mean? What's another way of saying that? Somebody said it. What? Yes. What question are you trying to answer? Get it? Isn't that what you did in your labs? If you made a good observation, what does your brain do? Hey, I wonder why that turned blue, or why that turned yellow. Next. Then you make a guess. I think I know why it changed from blue to yellow because, and you make a guess. And what's that called? But how do you test a hypothesis to see if you're right? Like, who in here blew in the straw? I forget. Okay, thank you. That's right. Did it change? I put an indicator in there, didn't I? And the indicator changed from blue to yellow, or almost on the way to yellow, right? Maybe green. And then I did some other things. When I put some acid with BTB, what happened to an acid? What happened to the BTB when I put it in an acid? Blue to yellow. So my hypothesis was that something in his breath combined with the water and made an acid. And you did. You made carbonic acid, didn't you? All right, and then you try, this is the hardest part, to perform an experiment to test the hypothesis, and you make a conclusion about your hypothesis. Okay, you okay with chapter 1? I bet you can almost write the 8 questions I'm going to ask. I bet you can almost see them, can't you? What 3-letter chemical was destroying the ozone layer? Can you see that? You can almost, I bet you can almost see what I'm going to ask. All right, next. We did a lot. Every time we did demonstrations or your lab, I said, look for changes in matter. Now, there are chemical changes and physical changes. Let's make this easy. Let's make it easy. If you don't change the chemical, then it's a physical change, isn't it? What if you let something melt? What if ice melts? Ice is made of what chemical? H2O. What's the water made of? H2O. What if I turn it to steam? What's it made of? So what kind of change was that? Anytime you only change from solid to liquid to gas, what kind of change is that? Physical. Every time that you put lit that candle, some of the solid wax changed into liquid, didn't it? What kind of change was that? Physical. Now, burning is always a what? Chemical change. Burning means combining with oxygen in a chemical reaction, doesn't it? Burning is always chemical. But the heat that melt the wax, that's a physical change. Then the wax changed in from a liquid to a vapor, didn't it? A gas? What kind of change is that? That's also physical. But then the vaporized candle burned. What kind of change is that? Chemical. Okay. The indicator chemicals would indicate almost always there's a chemical reaction. When something changed, when BTB goes from blue to yellow, that means I'm not an acid, but now I am. That means there was a chemical change, wasn't it? So the indicators tell me there was a chemical change there. If it changes blue to yellow, for example. Let's go on. Let's see. What else? What do you think? What were the bubbles when you put the Alka-Seltzer in that lab? When you put the bubbles in, put the Alka-Seltzer in water, what were the bubbles made of? Carbon what? Carbon dioxide. You're right. All right. Next. What happens if you were to burn a piece of paper? What kind of change is that? Burning is always chemical. What if you let rubbing alcohol evaporate? I put it on the table and all of a sudden 5 minutes later it's gone. Physical, right? That's changing from a liquid to a gas. What if I burn the rubbing alcohol? Then it actually combined with oxygen. That's a chemical change. What if, remember the big blue bottle? At first, I shook it because I wanted some of the liquid alcohol to change into a gas. That's physical, right? And I wanted it to mix with air. Mixing, what kind of change is that? If I mix something? Physical. If you just mix salt and water, physical. If I mix air and vaporize rubbing alcohol, what kind of change is that? Mixing is just physical. If I mix things and make a salad, what is that? Physical. But then what did I do after I got to mixing? What did I do? I lit it. What was that? That was a chemical change. You're getting better at that. What did I add to vinegar to make bubbles? What chemical, white powder did I add? Do you remember? What was it? Baking soda. So when I add baking soda to vinegar, it made bubbles. What were those bubbles made of? Oh, we're getting a theme here, aren't we? Are we catching a theme? Okay, now, when I poured the invisible gas into a beaker that had a candle in it, a lit candle, what happened to the candle flame? So that's a chemical thing, isn't it? So what's the chemical property of carbon dioxide? Does it support burning or does it extinguish flames? That's a chemical property of CO2. What's a physical property of CO2? And why did it come out of the container? Where did it go? Did it go up? When I poured this way, did the gas go up? Or where did it go? It went down. Why did it go down? You haven't answered one all day. Come on. Why did the CO2 go down? Is it more dense than air or is it less dense than air? See this pin? It's more dense than air. That's why it went down. What about carbon dioxide? More dense than air or less dense than air?
Less than.
What is it?
Less than.
You had a 50-50 chance of getting this right, didn't you? If it's less dense, you know what? Like helium, it's going to go up. Did carbon dioxide go up? When I went like this, I poured that big flask. It poured itself in. It fell into the beaker, didn't it? What's that mean? Okay, if I take a rock and put it in the lake, why does it go down?
Because of the
Rock is what? The rock is more dense than water. That's why it went down, isn't it? What if I go in the lake and I put a bobber? You go fishing? Are you a fisherman? Oh, do you know what a bobber is?
yeah,
Okay. If I put a bobber underwater, let go of it, why does the bobber go up?
because it got
Is it more dense than water or less dense? It is. So when I poured that gas out, it went down in air. What happened? What does that mean?
it's more dense.
Yes. So carbon dioxide has a physical property of what? What's the physical property of carbon dioxide? More dense than air. Okay. Next, let's talk about this group of chemicals that tell us when something's going on. What do you call that group of chemicals that they change color and let you know that something's going on? J3, you haven't said anything all day. You gonna help me out here? What do you call a group of chemicals? They change colors and they tell you that something's going on. Starts with an I. It's on the study sheet. What do you call that group of chemicals that change colors and let you know that something's going on? Starts with an I. It's right here. Indicators. So BTB is an indicator chemical, isn't it? Does anybody know what it indicates? Who knows that? Alana, you haven't said anything all day. What is BTB? What does it indicate when it changes from blue to yellow? What's that indicate? Yes. Everybody get that? So when it's a base, when BTB is a base, it's what? Remember the pH scale? Let's do the pH scale again, second time. pH scale goes from 0 to what? Okay, and the middle number is what? So if you're 7, you're not an acid or base. What letter comes first? A comes before what? Acid numbers are the low pH numbers. Base numbers are the high pH numbers, aren't they? So if you put BTB in a pH of 8, 9, 10, 11, 12, 13, 14, it's going to be blue, isn't it? When it gets around neutral, it kind of goes to green. But then, as soon as it gets into the acid pH, what's it change? So it goes from blue to yellow. Now, again, you might see green. If it's a fast change, you won't see the green. Everybody got that? So if you go from blue to green or blue all the way to yellow, it means you're becoming an acid. So here we go. In an acid, BTB is yellow. In a base, it's blue, and it might be green if it's kind of neutral. What about another indicator chemical called litmus? What's the memory trick for litmus indicator? Blue to red. Acid. Okay, so if blue litmus paper, this is litmus, this is not BTB. Blue litmus goes to red, what's that mean? Acid. So if you have a piece of blue litmus paper, you put it on something, it turns red, that means that's an acid, isn't it? What would happen to blue litmus paper in an acid? What does blue do in an acid? Nothing. Stays blue, doesn't it? Okay, let's go the other way. If you remember that blue to red, acid, then what's the opposite of that? Red changed to blue is a what? A base. So don't memorize both of them. Just memorize one of them. You get that? You memorize one, you got them both. What do you think? I'm not trying to go too fast. I already went over this before. This is the second time we've done that. Let's flip it over. Let's do Michael Faraday real quickly, and then we'll go back and do the other thing. Michael Faraday, what time are we talking about? About when are we talking about Michael Faraday? What? About 1850s, right? Okay, so mid-1800s. He did not become famous because he did the candle lectures for teenagers. You get that? He did not become famous because of that. He changed the world, not because of the candle experiments he did, but what? What did he discover? The connection between what and what? Magnetism and, yes, electricity. And with that, you can make what? What can you make if you were to turn the crank? You provide the mechanical energy. You make the magnets and the wires interact. What can you make? Electricity, right? That's a generator. That's a generator, right? The whole world makes electricity with generators. You get it? No wonder he was knighted. No wonder that was a great discovery of his. What if you put electricity into that same machine? What do you get out this time? I'm going to put electricity into that thing. What do we call it? Because if I put electricity into it, something will turn. The middle will turn. I can put a wheel on it or a crank on it or a gear on it. Electric motor. Not an engine, not a gas engine, but an electric motor. Those two things changed the world. All right. Next. Is that about it? Okay, let's go now. The biggest part, now I'm going to be nice to you. Originally, I told you had to write an essay and have all those words on there. I'll be nice. I'll write the story, and I'll leave in blanks. And then I'll give you a word bank. How about that? So, do you want to start the story? You want to start the story? Yes.
Do you have to know the 2 blanks about the invention?
About what? I'm sorry.
The motors.
Oh, the motor? The motor where electricity flowing through the motor creates mechanical energy. I didn't word that very well, but when electricity goes, that same thing that was a generator, if I put electricity into it, it'll turn a crank for me. It'll make an electric motor. So, all right, good question. Thank you very much. Yes? I can't hear you. Oh, am I frozen? Yeah. But I am. It is frozen. See my hand? My hand's over here, and so I hand it. So she asked a question down here. The invention of the motor. where electricity flowing through the motor will create energy of, called mechanical energy, the moving of a wheel or gear or something like that. Everybody okay? Now, here's the hard part. Why don't we start with Leilani? Let's try to tell the story of the science of a candle. I'm going to read the first part here, and when I get done, you can add any sentence you want and pick one of those words and see if it makes sense, okay? And say it real loud so everybody can hear it. The candle is made of an organic compound. What's that mean? What's organic? So it has carbon in it, okay? And by the way, it's not only organic. Not only does it have carbon, it only has what? It only has what two? Hydrocarbon means I only have what two elements in me? Uh-oh. All right, what's a hydrocarbon? Is paraffin a hydrocarbon? Yes. Is it organic? Yes. What's a hydrocarbon? It only has hydrogen and carbon. Okay, here we go. The candle is made of an organic compound, which is also a hydrocarbon called paraffin wax. It has the formula of C25H52. See how it only has carbon and hydrogen? It has been mixed with what? That's another chemical, isn't it? And why would you want to mix it with stearin? Because it'll cause the candle to burn longer. And do you know why? Because it does what to the melting point? Raises the melting point, so it takes a lot more heat to melt it, so the candles will last longer. The wick is made of absorbent cotton fibers that are braided, and they have been mordanted or pickled. Okay, Leilani, you want to help me out? How about one more sentence? Anything you want to tell me about that? About why did they want to do that? I'm putting you on the spot, aren't I? How about you? Go ahead.
Doesn't that help or cause, I think it's like the capillary attraction?
Say it a little bit louder.
It helps or causes the capillary attraction.
It makes it not smoke as much, and also an ashless. It makes it not have ash. All right, ready? Add another sentence now. So we can start the story by saying, when the wick is lit, go ahead. When you light the wick,
When you light the wick, there is
the heat from the
fire is burning off.
what's burning the wick, but the heat's doing what? It's got to do something to that candle. Did you have a chance to write this story with your group at all? All right, let's tell the story then. So the heat from the wick does what? Melts the wax. That means it changes from a what to a what? What do you change when you melt something? What do you change it from a what to a what?
Liquid to gas.
No. Like when ice melts, what do you? From a what to a what? What is melting?
Liquid to solid.
The other way.
Solid to liquid.
That's it. Everybody got that? Okay. Okay, so then, hey, you weren't in here. I don't know if you can tell the story, but after the wax is changed to a liquid, what happens there?
It's down the candle.
No. Well, I'm not trying to say if the candle is tilted, it'll run down the candle, but how much time do you have? Okay. What I would suggest is we had some time in class to do this. Go home and try to write the rest of the story using all these words. And then I think you're going to be ready. I think you're going to be ready then. All right? Oh, by the way, I am going to have a picture of a candle. It's going to say, point to the luminous zone, point to the dark zone, point to the reaction zone. And I'm going to ask you the temperatures, so you'll have to label the temperatures, all right? So that's a given. I'm definitely going to do that for you. Well, I thank you for doing that. I couldn't find my copy of it, so thank you for letting me borrow that.